in this question, we start off with the fact that O is the center. So let's go and mark that out. And let's see what else could it give us. Okay, could it give us angle at center equals angle at circumference? I think that could definitely work. Okay, so I'm going to call the O1, I'm going to call it the X, the 2X, sorry. And then the one that this AB arc makes at the circumference is going to be the X. Okay. Do we have tan rad? I'm just looking a little bit ahead here. OA is a radius, AB is a tangent. They're clearly trying to alert us to tan rad. So yes, we do. So A2 plus A1. I'm just going to make my box covering both of them. We've got tan radius. And then do I have some radii that help me get more angles? I just want to draw your attention to something here, and then I'm going to delete it. Have a look at this section here. Where are their angles? Do you see that it feels like there's going to be an angle made with the circumference of the circle, and that's never going to be something, okay? So in this section here that I've highlighted in turquoise, your B2 is going to cover from the line OB to the line DC, and we'll come back to that because it's one of the questions. Okay, so be very careful to not create now angles opposite equal radii. And I know I can't because there isn't a line going from A to B. Okay, so it isn't a straight line, so I don't have angles opposite equal radii, so I'm not even going to put that radii thing down because I think it's actually just going to be confusing at this point. Okay, the circle passes through A, B, and C. Why are we being told that? A, B, and C. Okay, so that's obviously to alert me to the point there. Okay, and I said that B2 is going to be this angle here. Okay, between OB and the line CD. Okay, OA is parallel to BC. Let's go put that in. And let's see what that gives us. With parallel lines, we're going to have our fun angles. So with OA being parallel to BC, I can see there that my 2x that I've put there is going to be a 2x here as well. So I'm just going to mark that as a 2x. Again, I can come back and change that at some point. And I've also got an x with my parallel lines, so that means, as in this x here made by O, B, and then AC, and that always means I've got two sets of alternate angles. So that means my A2 is going to be an x as I marked C there. Okay. AB is a tangent, I got that. Oh, sorry, AD is a tangent and meets CB produced a D, O and B is joined. Okay, all of this stuff has pretty much been covered now. Let's look at the questions. First up, I've got to prove that A1 and C is 90. Okay, let's have a look. Where's 90 going to come from? I think the only thing I can see with a 90 is that we've got A1 and A2 is 90. But hang on, A2 equals C. Okay, so we're sorted. So I'm going to start there by saying A1 plus A2, that equals 90. And my reason is tan rad. Then I'm going to say, but A2 equals C. What was my reason again? It was alternate angles. Therefore, A1 plus C also equals 90. So for the next one, I'm leaving up what I answered in purple here, the A1 plus C equals 90. I'm leaving that up because I think I'm going to use it again. And I know that this questions will scaffold, so I'm expecting I might have further use. The second thing I've got to do is I've got to prove that O1 equals 180 minus 2 of A1. Okay, so what I'm going to do to get that is I'm going to look at what O1 equals. Okay. O1 I got as 2x. And I just want to think, I've got to do O1 in terms of A1, but A1 had something to do with C over here. There's something going on with the 180 and the 90 and the A1 and the C. Okay, so O1 I got as 2 of angle C. Okay, that was angle at center. And then C, angle C, was inside this purple thing. Okay, so I've got angle C. C actually equals 90 minus A1. I'm just rewriting with C as the subject of the formula. But O1 is 2 of these. Okay, so therefore O1 equals 2 of my 90 minus A1. Okay, what am I supposed to do? I'm supposed to prove that O1 equals 180 minus 2A1. Can you see I'm there already? So what I've got there is I then have O1 equals 180 minus 2 of A1, which is what they wanted. I've also left up that I had to prove. I've then got to prove that B2, and this was this angle here that I was pointing out earlier that's a little confusing. Prove that angle B2 plus 2C equals 180. Okay, so locating it I think was first an issue. B2 and B1 are on a straight line together, so I'm going to start with that. Okay, so B2 is actually the same as 180 minus B1. And my reason there is angles on a straight line. Okay, so what was B1 again? B1 was the same as O1, and that was alternate angles. So these are all things I got right from the beginning, and I think that's why I stress going through the paragraph so much. Alternate angles because of AO being parallel to DC. Okay, but then I had O1, right? O1 was the same as 2C, which I'd proven, with angle at center. Or I could say angle at center. Okay. And then, what am I trying to get again? I'm trying to get B2 and 2C to be 180 together. Okay, so far I've got the O1 linked to the B1, which is linked to the B2, and then I've also got the O1 linked to the 2C. So you see what's happening? I'm putting them all together. Okay, so I said that B2 equaled 180 minus B1. So therefore, B2 equals 180 minus anything else that's equaled to B1. And B1 equaled O1, and O1 equaled 2C. Okay, so I'm just going to lay that out and say B2 equals 180 minus O1, which also equals 180 minus 2 of angle C. Okay, therefore, if you can see they're just rearranging it, it means that B2, if I now plus the 2C on the other side, I would then get 180. So it was really about rearranging stuff in this question.